All right, guys, Alessandro and Max from ZRush. Great to see you here, and I'm also very grateful that you take the time to have a proper presentation like this of your second milestone. And I'm really looking forward to what you have to show. So, no further ado, let's go.
Okay, maybe I'll start talking. I'll just share the screen 1 sec just to show what the milestones were. So where we're at now. So we are currently presenting for milestone number 2. We did milestone number 1 a couple months back. So we have the design parts already set up. Did a bit of quite a bit of other work in other areas. I'll talk about them. I'll talk both about exactly what we did for the milestone and also for a bit of extra things at the end if we got time. But basically for this milestone is the idea is setting up everything that we need so that we can start actually building and testing the model for the 3D mapping and for the reconstruction of 3D environments. So for this milestones, we have this presentation on system architecture, data acquisitions, how we plan to do it and where we got so far, and a literature review and a bit of competitor analysis that we're starting as well. So maybe Max, you want to start if you got them ready with the techie parts, and then I can talk about what we did from a more from a literature, articles, competition, and a bit of market analysis point of view.
Let me thank you, Alessandro, for sharing this sheet. This is part, as you can see in the tabs, of a bigger sheet that is also published and available to the community for everybody who would like to keep informed on what's going on. The same information is also updated on the portal, so also there you can see the original proposals, but then with the completed milestones and some links. But maybe I should find a way to republish this at a place, this link where it can easily be found always by everyone. So thanks for just quickly showing this.
Okay, so let me share my screen then. So let's go here, share. Okay, so first thing, we are starting to understand how to design the architecture of the interface. We started to figure out what were the tools, what were the libraries, the APIs that we might find useful to speed up the process of development. So if we look at this diagram, we can see first thing, this layered architecture that goes from the front end, so the user interface, what the user can see for controlling the drone, and then all the way down to the hardware, which could be either simulated hardware or real one, yet to be defined. For the designing interface, we chose Unreal Engine for mainly 2 reasons. First reason, which I think is still very important, is that I already had experience with it, so I already know where to put my hands. And but also we found that there is a very nice API for simulation of aerial vehicles developed from Microsoft. It's quite interesting that this API actually got so the support for this API was dropped very recently, like a few weeks ago. And this is because Microsoft is going to, let's say, build on top of that to make their own development. which is now secret though. So, but all of the API stays open. It's open source, and we can access it. We can fork it. We can modify the code, and it's actually very convenient tool. Regarding the what Microsoft is doing, I think it's interesting because it shows that there is interest even from these big tech companies towards this kind of aerial autonomy and drone control interfaces. So I think this is actually good news for us because there might be interest and there is a good market. I mean, there will be also good market in the future. So if we go a little bit deeper into this diagram, we can see that the graphical interface will feature this interactive 3D render of the working area. So here I've just listed a few examples, but following the conversation that we did in the last days, instead of having these industrial scenarios, we might even have like sport events, concerts, or this type of environment. And let's say the way that the interface will be designed will be inspired by video games, but that's because video games already have a very good, let's say, knowledge on how to make an interface appealing, usable, easy to use, easy to understand, easy to interpret, with the right information in the right spot, with the right buttons, with the right features. So we are kind of taking inspiration from that design. Then we have the render of the robots that we're using, which could be interactive. So you can select, you can click, you can move them, and exactly in the same way you will do in a video game. We have a mini map to show what where the robots are with respect to the environment. And then we have some buttons for controlling as well, like take off, land, scan this area. So at the moment these are the buttons we have developed so far. And we also want to add some info on the heads-up display to show, for instance, the camera feed, the location, the battery level, the altitude, the sensor readings, all information that might become useful for someone controlling the robot. So under the interface, there is an algorithm part. The algorithm part is mainly split into two groups. One that is not, let's say, is not for user. For the user to interact with, which is the aerial autonomy part, which is let's say, making the robot move autonomously in this hybrid way. So we can either control the robots to tell them go there, but then we also want the robot to be able to take this low-level local decision, whether if they're going to break into an obstacle, if they're going to collapse into each other, or in case of reaction to strong winds, all of these kind of things, they have to be taken into account when developing the algorithm for moving the robot. And then we have the other part, which is the sensor processing algorithms. And in that part, this is for the user to decide which one to activate, which ones are useful. Maybe you have some parameter tuning. You can have the algorithm to be more focus on something and not something else. So in this case, I'm mostly highlighting the 3D mapper part, so the one that we agreed that we will be developing for this grant. So to do this, we are going to need pictures and GPS locations of the robot, which is something that we already started acquiring in the simulated environment. And then we can use those data already to test the algorithm. But then also we can add others. So let's say, for instance, we want human detection. This was when we were thinking about use case for surveillance, for instance, or full robot detection. This is has to do with the proprioception. So if the robot has some fault, if it's so it could be a motor fault, it could be a failure in the localization, it could be a failure in obstacle avoidance, and that is actually crashed into something. So there could be several, let's say, trigger that send an alert, an alarm, or others. So this part can be extended with any other type of algorithm, that depending on the kind of sensor we have on board, of course. So let's say for the moment we are going to stick with drones with onboard camera and onboard GPS, which is the most widely adopted set of sensors on commercial drone available at the moment. If we go one layer down, we see we have the API, which is in charge of sending the command to the robot, acquire the data from the sensor, and it's actually also in charge of simulating in a realistic way the robot behavior. And this part is the one that puts into communication the more higher level layers to the actual hardware. So that could be either simulation or real robot. So now when we will be done with the simulated part, we could simply replace the simulated robots with the real one. Now I'm making it too simple, because of course there is this simulation to reality gap to be considered, but keep in mind that at the moment this simulation environment are very realistic, so we can generate very photorealistic images. Also, depending, of course, this will depend on the quality of the scene we choose, of the environment we choose, of the simulated environment we choose. So the idea will be to then, when moving on the real robot, will be to still use the same graphical interface that we use in a simulation, but simply feeding the 3D environment. So let's say generating the 3D environment with the data coming from the robot and processed by the 3D mapper. So if you have the robot exploring an area, the images and the GPS location are sent to the 3D mapper. The 3D mapper will then generate the 3D environment and populate the interface with the 3D render of the scene you're exploring, of the environment you're exploring. So now if we move to this part, we can see how this system will require a distributed architecture, because there are some part of the architecture that need to be run on board. This is for an obvious reason, because if we want to have fast and local reactions to local changes, to local obstacles, we want the lowest latency as possible, and we will need to have some onboard computation to run mostly the obstacle detection and avoidance part. This is actually something that I have already been working on during my master thesis. I actually published an article, scientific article on path following and obstacle avoidance for aerial vehicles with onboard computation. Of course, that was a research project, so it didn't have any industrial requirements. So this was the part that I was talking about earlier. So we have this aerial autonomy part being computed on board, and we see here that for doing this, not only we need the obstacle location, but we also want the other robot location. This is also to activate this swarm intelligence behavior, where not only the robots avoid to collide into each other, but also distribute the work in an intelligent way, so that they can split, so they can parallelize the exploring task, for example. But not only that, we could even have area coverage during a concert, during a sport event. We want to cover as widest area as possible using only one control interface, and then therefore only one user, so one operator, which is then the main idea of this project. Then if we move here, we see, so these are basically it's just the things I was explaining before, just shown in this distributed way. So how this algorithm will be deployed. So this part here will take, this part here of the 3D mapper and other sensor processing algorithms will be hosted on the SingularityNET AI marketplace. Yeah, so I said already everything from here. And whereas here we have another part, which is actually which is going to be hosted on the either a mobile platform or a laptop, where you have the operator controlling the robots. And in this part here is in charge of aggregating the data and sending them to the algorithm, so to the 3D mapper, and receive the data back and render them into the graphical interface. So this is, let's say, the main picture of where we want to go with this interface with our algorithms. And I have here, I can show you. So we already started development of the interface on Unreal, and I can show you, let's see, some videos maybe. Okay, so this is the thing that I was telling you before. So we have this 3D render of a whatever scene, and this is one of the let's say default scene from Unreal. And we have on one side we have this mini map where we can see all of our drones and their location. We can use the icons on the map to select the ones we want. Now, of course, don't look at the statics because we didn't have put any effort in making this beautiful yet, but we actually have Alma and which is part of our team, which is a UI UX designer, and she's gonna help us in making this more appealing and usable. Also, we can see that, so I can both move my swarm, so I can control my swarm. I can see the feed of the cameras, and I can keep track of all the drones in the scene. Not only that, but I can even use this environment to record data, and I'm gonna show you a small extract of this data. So the thing that we can extract from the environment will look something like this. This is a swarm of drones moving in the scene and collecting images while moving. Sorry, this image viewer is not the best, but so you can see that it's basically frames of the path along which the drone has moved. Not only that, but we can even extract this kind of file where we have, for each drone, we have and for each frame we have the position and orientation of the drone for when that image was taken. And so this is these are the main ingredients for the 3D mapping algorithm. So this is data that we're going to feed into the algorithm and hopefully extract this 3D reconstruction of the environment. To do that, one thing we needed is computational power, and actually at the moment I'm running on my laptop, which is not the best when it comes to rendering 3D environment from multiple cameras. So actually part of the budget we have from your grant was spent in buying some computational power. So we have we just bought a new machine where we could actually that I will need to assemble this weekend, and on that machine, on that workstation, we will be able to rerun this acquisitions at a much higher rate, with higher resolution and with better just better quality data that we can use to run the algorithm. I don't know if I think I'm done with the technical part. So maybe Ale, you can take the stage.
Sure, thanks.
If I'm forgetting something, tell me. But
no, I think you're good. My part is way less interesting, but I'll just show you how we've been operating on the research side. So basically, what we've been doing is setting up. Where is it? I'm sharing my screen again. So basically, from a literature point of view, what we've been doing, we have this shared file where we are putting and kind of categorizing the articles that we found useful. So we didn't just put everything in. We actually put things that we would like to investigate or that we have been useful for one reason or the other. There's quite a few different category of articles and research work that we have recorded in here, along with a way of with a short description of what it's talking about, so the topic, so that we can find back easily without getting lost. We have general swarm robotics things like these, which talk about research platforms, about current applications, a bit in general about what robot swarms is. Then we go a bit more in specific. There's about market sizing, especially in the UK, as we are about to present the grant for Innovation UK. So there's a bit of market research and impact on the UK market that we've been looking at quite extensively. Still other things on swarm robotics, going a bit more specific into the algos that then at some point we will need to use, especially when we get out of the simulated environment and deal with things like connectivity issues or target movement. For example, if we want to record, I don't know, someone skiing, you want to follow them, right? So we have things like cooperative navigation. There's some targets, multi-target tracking, where the drones follow the person that they need to take the video of, things like that. And also we have, where is it? Yes, quite a few articles on different techniques for the 3D rendering for the stitching, which is both, let's say, a bit more review of old school techniques and also more new machine learning, deep learning based techniques. There was this one, the convolutional neural network one, which is found really interesting. I also worked with neural nets in my master's thesis, and I know how good they are in processing images. So we're definitely going to experiment that to get kind of this dynamic mapping reconstruction, which we need. So this is mostly, we'll keep updating this as more goes on. So we're keeping this kind of a repository of information where we can access it quickly. What we started doing, and this was a bit recent, so it's this is way less formulated, but what we put here is basically a list of different swarm projects and of also different competitors. So here we actually, next task is to go through these and see what they can do, what they can't do, what their the exact application is, to try to understand, are we filling a gap or is it already been done? So most of them, we started with the swarm robotics, with all the swarm robots that we could find in the industry applications. And now we started looking at those which are more for drone software. We also started looking a little bit at drone hardware. There's some interesting advancements that have been doing with docking stations, which are now super expensive, but they're really interesting because they're solar powered automatic docking stations where the drone lands on top of it and gets recharged by induction. They are like prohibitively expensive at the moment. They are like in the tens of thousands for one docking station. So not exactly what you want when you're trying to make the cost per robot less. So this is mostly a lot of ongoing work. We are filling this up, and especially now in our writing the grants, like this competition analysis is really what we have to focus on, as there's a little bit of we don't know too well what's going on. We have a brief general idea. So this is for let's say what's in the milestone, but we have been doing other advancements as well in parallel, because we set those milestones, what was it, in June? So the project and the idea behind the project and how to get to the goal has evolved a lot. And I think that that's one of the best things that that we're happy about, of how it's evolving and how we are trying to. The hardest part is, I think, that basically we know what the dream is. We know what we want to be ideally in 5 years, right? We would like to be a platform, a software company that, whatever the type of robots, whatever, like kind of on a consultancy basis, right? So someone comes in and says, "Oh, I want a project with I need to get to extract some objects from a sunken ship or something." Right, and so they come with the specs of the project. We have the robots custom built for them from a partner. We design the software interface for that exact type of swarm, for those exact capabilities, and we sell the project. That's the 5-year dream. But it's not something that we can go to the market with without just saying, yes, we'll connect to whatever type of robots, to whatever type of application you want, and we'll do a custom project for you. I don't think anyone will buy us in that way. So what we are trying to say is, how do we connect the dots and get to that? And the idea is to basically have a pre-built, at least for let's say year one. I would hope if we manage to do one other year or secure a little bit of other funding to be able to go on for 1 year, we would like to get to a place where we have a drone swarm which is preset, which it's just cameras and GPS, so very simple drones, not too many sensors on it, not a lot of data processing and analytics that would take a lot of time out also. So a set of drones with the platform that we can either just sell to someone. So if you want, as a private customer, you want to buy it, you can buy 5 drones plus the software to control it, maybe get a training package or something. Or we can do it on a project basis, as in okay, you want to rent the drone swarm for a weekend, and we send an operator that puts 5 drones, 10 drones in an environment, they scan it and then controls them to perform the actions that we want. And we got really happy for last week's conversation, and I'd like to thank you again and the other guys in the call as well, because the use case, we were struggling a lot on finding this first use case that doesn't require too much extra sensors and data processing and analytics, and that's actually feasible to do with a swarm, and that also needs to not be feasible from a single drone, because otherwise why would you get a swarm, right? If you can just do it with a single drone. And we were thinking a lot of things, and everyone had its like cons. At some point we ended up in like surveillance or like security instead of security camera, but that had a lot of cons anyway, apart from that it's not really a fun use case. But also it's like you have to deal with with recharging, you have to deal with the fact that if it starts raining or there's too much wind, what's going to happen with your drones, especially if they're cheap and lightweight drones, then your security cameras will work for until it rains, right? It's not the best. So that the use case of actually saying, okay, what's we spoke about last week, and also a bit what we spoke in this metaverse conversation this week, which was, okay, what are people doing with drones at the moment? They're mostly using it to take pictures, to take videos, a lot for entertainment, right? That's probably one of the main use cases. Someone buys a drone, sends it, takes a really nice pic of the landscape from 100 meters high, and they're happy with it. So we actually talked a lot about it this week, and we decided, okay, that's definitely one of the best use cases, as in just the objective is for entertainment purposes, as in recording videos or taking pictures or doing the rendering, which then we can talk about once we know a bit more about the metaverse stuff and virtual reality. Definitely happy to keep talking about that. But for the moment, it's more like, yes, taking pictures at events. And we were thinking it's also, apart from the fact that it covers all of the problems, because you don't have problem with recharge points because it's a limited environment where if at some point the drone is stopping, it just goes back to the operator plugs it in, puts another drone in the air and alternates them. So we don't have to deal with the automatic going back, stopping and going up, which adds a big layer of complexity. It also doesn't matter if wind, rain, bad weather, you just don't put the drones, you don't fly them. So it solves a lot of these problems, and it's also apply, like the environment is a bit smaller, so it's more limited. There's a bit more room for wiggle error in these. Like for, I think it's an easier use case. It's more fun to do, and it's I can see it going somewhere. And even what we were thinking, one thing is that when it's in point, we build, first the 3D rendering part, then the algo to control the swarm movements, so the swarm behavior, and then we start moving from simulated environment to real world, so we actually connect the drones. Once we have this in place, which it's not unrealistic, it's not something in 2 years time, right? We can already do something where maybe we know someone that's at a wedding or something, and we ask them, can we take pictures with the drones at the wedding for free? And that way we can test and collect data for our algo in a real world environment, without having to pay or without risking people complaining, because what's gonna happen? I mean, worst case scenario, you get a very lightweight drone dropping on your head. That's the worst case scenario that can happen, right? But if you instead, if you think about it on in industrial setting use cases, the fail case is way worse. So I don't see industries being so happy to say, yes, sure, test your drone swarm sci-fi algo in our premises and take all the videos you want and things like that. So I think this approach that this suggestion, this use case is really, really good. So we will focus with this in mind, which also gives us a way to lighten up the design and make it maybe a bit more flashy instead of being the very much grays and whites and blacks. Yeah, so that's mostly our conclusions, our work. As I said already in our chat, in our bi-weekly meeting, we are continuing with the dev work. The idea is that is our primary focus. So to get this rendering algo out as soon as possible, and try to not worry too much about the other parts until this is done. There's obviously some work in parallel to try to get some grants or to start having introductions with private investment in private equity. And also there's the design work, which we also have in another milestone, the rest of the design work for all the interface and website and everything, which will help us have a kind of a actual product, which is nicer to look at, and that's ongoing. So we have our designers working on that and helping us out. So that's where we are. 1 minute to spare for questions.
Well, if you have the time, Ale and Max, we can spend a few more minutes if you like.
Yeah, good for me.
First of all, thanks a lot for this presentation. I really appreciate the thought and the care that you put into it. Also, not just for me, but mainly also for the community. And also for other teams, current teams and future teams, or people who are thinking about submitting a proposal. I think what this shows, what stands out for me, is that for SingularityNET, this is really a good direction to fund young teams like yourselves who are completely focused and enthusiastic on a certain idea and then go all the way. I don't think we would be able to do that ourselves with the same amount of funding to go with that much attention and laser focus to that area. And I think that's lovely to see. Also compliments on the structure you put into it. I think it's really professional approach. It looks very clear and convincing, especially the part where you're purposefully not trying to reinvent the wheel. And you do that I saw that in different areas appear. For instance, saying that you are looking at the UX of gaming and then borrowing that for your own solution, which is absolutely perfect. And of course, also that market review and that competitors overview to see what does the landscape look like. Also from a technology point of view, what technology is there that we can already reuse, that we don't have to reinvent. So yeah, I think it's a smart approach on multiple levels. So I'm really happy with what you're showing me and makes me enthusiastic. And I've no doubt that proper use cases and different use cases that we think about today will pop up as you go along and as you learn about the possibilities, perhaps also about limitations. It's not unusual for startups at some point after a year or something to pivot and to start focusing on something that used to be a supportive technology and then starts to become the main technology. But we'll see. I think your long-term vision is sound. I think I also like the idea that you already distinguishing or differentiating between offering it as a kind of full package service or as a product, where maybe in the beginning a product might have been more the basic idea. Doing it as a service might actually make a lot of sense indeed. Covering people's weddings, and it's not only for photograph, but you can switch from photograph to volumetric display, put it in a metaverse. If I would go out and marry in Italy, for instance, then my family here in the Netherlands could still enjoy and be with me in the metaverse, just saying something. So yeah, there will be plenty of use cases, I'm sure, and I love the structured approach. Also, it occurred to me when you talked about funding and phasing. So I think it's good that you focus on a part and don't try to do everything at the same moment, because that also allows you to evolve your ideas. And we had that talk at the beginning, Ale, before you proposed. Should we propose a big assignment in one go or go with smaller chunks? And we ended up with a little bit smaller chunks because that would improve the option to be selected. But I think another opportunity, which I may not even have thought about back then, but becomes apparent now, is that it also allows you to investigate and explore and be more flexible. And after this first stage, and you're absolutely welcome to come back in the next round to propose for the next part of your solution. But then with the acquired knowledge from all the research that you're doing right now, I think you will be able to make an even better proposal than you would have been able to do a couple of months ago. So that is also a learning and an insight also for other people out there who are thinking about creating a proposal for a next round that might be helpful.
Also, if I may add something, regardless of the use case we will end up focusing on, there are some, let's say, ground thing that we still need to develop that will be common to any possible use case anyway. So while we are thinking, while we are exploring, while we are try to understand and analyze the market, the competitors, and so on and so forth, we still have things to develop in the background in parallel, so that will still be useful in the future, regardless of the things we will decide.
Absolutely, and yeah, I think that's a sound idea. So that 3D mapping renderer, I think that makes a lot of sense in itself. Maybe also for completely different use cases. So yeah, that's also a good strategy. Just a few questions that popped up in my mind while listening to your wonderful presentation. You talked about computing and computing power, and that was one thing that popped up. But the other thing related to that would also be bandwidth and data throughput. Is that also something where you expect issues, or do you think that's fully covered?
No, yeah, that is totally true. So let's say at the moment we are mostly focusing on a computing part rather than a bandwidth. But yeah, of course, when it comes to publishing the network, so the algorithm, we will for sure need to think of some way to increase our bandwidth. So I'm not sure, because so there are some cloud computing possibilities. We really need to understand whether it makes sense to buy and host computing power, or just outsource it and rent some from cloud services. I've had some experience with AWS. I don't know, because we also need to understand the pricing of those solutions, and come up with a comparative analysis to understand whether it's worthwhile going to cloud services, cloud-based services, or in-house services. Probably cloud-based will solve a lot of problems for us, because you don't have to deal with the maintenance of the server, of the infrastructure, and so on. But also it comes with some downsides, because of course, besides the pricing, you also have some limiting factors that come from the fact that you're actually doing your computation on a, say, public server, a server that is not just dedicated to that.
Yeah, so we don't have to have answers to all these things right now. It's a journey, and then there are different ways of attacking it. Talking about data throughput and calculation, one way would be to actually filter the data so it becomes more manageable, but maybe less detailed or something. There's of course also a difference whether you have 100 drones in the air for one user, or whether it's 3 drones. So. And that depends again on the use cases, I suppose. So there are many variables down the road, and also different strategies for solving these things.
So there is also another possibility to have, say, 2 versions of the algorithm, and one that can run locally online and can produce an output straight away, or one that can just sit on a server where you just send your data and wait for a result, which doesn't need to be as immediate.
Yeah, very good distinction. Also, different use cases.
Yeah.
And I can imagine you do both. For certain events, you can watch in real time in a 3D environment what's going on. But then afterwards you'll do post-processing with the real data and make a much better and more detailed recording of it. That's actually,
you can start with a coarse mapping, and then refine.
You can make a business case around that, just that. So you can ask people to pay for being there at the moment in low resolution, and then you can ask them to pay again, watch it back in higher resolution.
It's actually a good business model.
Yeah. Well, there's much ground to cover. We are at the early stages, but yeah, I'm happy to see such a structured look on that. Of course, when it comes to computation, some point down the line, it might also be interesting to have a talk with our brothers and sisters from NewNet, who are all about decentralized computing. But that shouldn't be your highest concern at this moment. One other question that came up to me, and that's the last one, I think, for now, is for Ale. You have been looking at competitors. did you already have some learnings on that? So things that you thought you would be unique in but aren't, or things that you thought would be there but still offer opportunities? Did you get any new ideas? If you don't have to publish your trade secrets here right now.
A little bit, yes. So, for example, the first thing is we learned that if you don't talk about the swarm, so about drones, softwares to control drones, scheduling, real-time control, there's a lot of that. So that was the first thing where, after seeing the amount and also the quality, like they're really good, really advanced, and there's some of them that do really advanced things. We've seen one, they got a use case, I think it was called Perspecto, or they got a use case where they fly the drone over solar panels and they tell you if the solar panel is damaged. So they do really complex things, both with it's less about how you fly it, but it's more about what you do with the data that you extract from the drone. So seeing how much of that, and also all these drones, they're starting to use the automatic docking station. They call it drone in a box solution. So they also have this feature where no one even has to start them and pick them up. You put a scheduled start and end flight time. The docking station opens up so that the rain doesn't fall in. Drone flies out and then comes back and the station closes. So this was the first part where we said, okay, we need to find a focus, and we need to find something where actually the fact that it's a swarm is a big improvement. We need to find something where you can't do it with a single drone, because otherwise the competition is too high. So that was the first part. And that's kind of, for example, we always loved the agriculture part, but that is something where, at least for drone data collection, it's a bit hard for us, and maybe I don't know too much about it, but it was a bit hard for us to justify why would you use a swarm instead of flying 3 drones that don't talk to each other and just schedule each one of them to collect data on top of a crop. And we couldn't answer this question. So when we researched a bit more, what are swarms doing in agriculture is actually a bit more complex things, such as they're actually planting seeds, or picking up like fruits or something like this. So they perform more actions, which would add quite a lot of complexity, because you need to have a robot that is able to do that. You need to sort out a lot more interaction with real world environments. It's already complex enough to avoid the drones from crashing into each other, I think. So we're trying to keep it simple, just to prove that those swarm algos work and that they're useful. Then when we looked at this, we've learned another thing. That's for swarms, the main industry where they're being researched and used is the military. They are really, like, they look pretty advanced. Also super expensive, each single drone, but there is where the research is focusing, which in a way for us is kind of good, because it feels like almost all the research is going in the use case we want to do the least. So maybe the rest seems a bit more open for grabs. And from an entertainment point of view, so this part here, we didn't find anything like what we were talking about. Like, we didn't find anything that does, combines the drones to take videos at the same time, or even, I think a cool part is, which needs to be a bit formulated, and it's a bit more complex from a flight point of view and from a technical point of view, but it's actually not have the drones just fly and each one taken a different video, but I combine those swarms to do photos and to take types of videos that you couldn't otherwise, like dynamic moving, imagine, I don't know, imagine maybe at some point someone's skiing and you have two drones flying on top and they take the 360 picture, something like that, something that's more on the artistic side. Need to figure out how to do it and when to do it, but it's something. And in the market we didn't find anything like this. In entertainment, there's a lot of the drone swarms are mostly used for light shows. So you have all these swarms flying with different lightings and usually some music playing. And there's a lot of Chinese companies, especially, who are doing this and providing these drones. I watched some videos; they're pretty cool. But so this is the most things. Other things is I've seen there's some stuff in space for space exploration and for collection of debris and broken parts of satellites and stuff like that. That's a bit out of the that's a bit too much of a dream. It would be cool, but it's
That's going to be a problem in the near future.
Yeah,
Space debris is going to be a big problem for.
I'm sure there will be other use cases when you go along, either from efficiency, that it's easier or better or more efficient to have 10 small drones doing things, and then you still want to make sure they don't bump into each other and are orchestrated, or indeed the amusement where people want to see a 360 of themselves while they are training for semi or professional sporters. That could even be a thing. So they can study movements. Just thinking on top of my head.
Yeah, I could think of skydiving, skiing, all those extreme sports where like having, actually when you do skydiving, there's one guy who is the cameraman who was there skydiving with you just for taking the recording.
I think security will be an issue there, like everywhere. But I think the main takeaway here for everybody is you did the research. And, sometimes when you start that kind of research, it can be demotivating because you see, and that always happens when you have a great idea and you think you are the first and you're brilliant. When you start Googling, and most of the time it appears that somebody else is doing it also, and maybe already more advanced or better or whatever. But the lesson here is that you do have to do that and don't stop and use that for learning and trying to sketch the landscape and learn from it and see which niches are still open or where you can improve or use what is already being made. So yeah, that is also advice to any existing or new teams out there. Don't sit on an island, but go out and learn what others are doing, and based on that information, plot your own course and continuously keep adjusting that too. So yeah, great story, guys, and wonderful. It's also such a wonderful use case that you can imagine. It's not abstract. And everybody can imagine this being a thing in the future. And we'll see what use cases will be most helpful. All right. Thanks a lot for the presentation. We're over an hour right now. I think that's a good time. I hope this recording will reach a lot of community members now and maybe also in the future. Maybe 10 years from now, when you want to look back how you guys started out all this. All right.
Thank you.
Thanks a lot. And looking forward to the next steps. And I wish you all the luck that you deserve.
Thanks, Jan.
Thank you, Jan.